In this video, we will see what is a demultiplexer. In the previous video, we have discussed about what is a multiplexer and how to draw the circuit. So here we will be discussing about demultiplexer. So it is also called as your DEMUX. Okay. So what is a demultiplexer? Basically, demultiplexer is a device where there will be one input will be there and there will be multiple outputs. So to explain, let us consider there are two outputs. Okay, let us say this is Y0 and this is Y1, let us say, fine. This is one input I have, let us say this is I0. In some cases you will find this as D also, D stands for data. So the demultiplexer is, so one input is there and I have to select whether this input will go to this particular output or the input will appear across this particular output. So whatever the value of the input, it may be 0 or 1, but it will be appearing across either Y0 or Y1. Now to decide this factor where it is going to appear, we need a selection line and the selection line will be S0 here, right. Depending on the selection line, we have to select that the input, whatever the input is there, it is going to appear across the Y0 output or Y1 output. In this scenario, it is called as a 1 cross 2 demultiplexer. That means one input and two outputs, and based on the selection line, I have to select that to which output the input is going to appear. So what will be the truth table for this? So we have a control which is S0 and we have two outputs which is Y0 and Y1, fine. Now if I have one control input, so I can have only two combinations, that is 0 and 1. So to design the multiplexer, we need to fix that whenever the output is equals, sorry, selection line is equals to 0, then the output will appear across Y0 and the second one will be 0 always. And if the selection line is equals to 1, then the input will appear across the Y1 output, sorry, Y1 output and the Y0 output will be 0. So this is a simple truth table to implement a demultiplexer. So what we have understood, there is only one input available, that is I0, and depending on the selection line, where is the I0 available, we have to see. Fine. In this scenario, the value of I0 can be 0 or 1, that does not matter, but depending on the selection line, this I0 will be appearing across the I0 will be appearing across the Y0 output 1 or output 2, that is Y1, fine. So and wherever the output is appearing, the other outputs will remain 0 in that case. So now we have two outputs here, so we need two Boolean expression to implement. So first output Y0 is equals to S0 dash, because if S0 is 0, then only this is going to activate. So this is S0 dash into I0. Similarly, where is the value of Y1? So Y1 will be equals to S0 into I0. So this is what we have understood, fine. Now we have to implement this particular logic circuit in our circuit diagram. So how to do that? Let us see. So I will just remove all the text and we will keep the logic expression or the Boolean expression and we will try to implement that. So to implement that, so how many variables I need? I need S0 as a variable, I0 as a variable, and there will be two outputs, Y0 and Y1. Now how to implement Y0? So if we see from the circuit point of view, then Y0 is what? There is a S0 and let us say there is I0, fine. So Y0 is equals to S0 dash, that means through a NOT gate S0 will be there and it is multiplied, that means with a AND gate the Y0 is available here, fine. And how to get the Y1? Similarly, Y1 is simply S0 and your input I0 with a AND gate, this will give me my Y1. So this is the circuit we are going to implement here. So I will just remove the circuit and we will try to implement that with the multisim here. So in the multisim, I will go to the circuit elements and I need two AND gates here. So I will go to all groups and I will search for AND gate. So I need a 2 input AND gate in this case. So I will take 2 input AND gate. So one I will place here and then another I will be placing here, fine. Next what I need a OR gate also. So to get the OR gate, sorry, we need a NOT gate, not OR gate. So the NOT gate will take, so that will be NOT gate, and one NOT gate is required, so I will keep it here. Next what I need the interactive switch to have my inputs. So this interactive digital control, so this will be my S0 here, and one more, that is my I0 here, fine. So this is the required things for me, so I will just rename it. So this will be labeled as, let us say, I0, and this one I will label as S0, fine. Okay. Now how to do the connection? So Y0, the first output, is equals to, here let me write Y0 also. So this one is Y0 and this one is your Y1, okay, fine. Now to do the connection, first one Y0 is what? S0 dash into I0. So S0 is there, it will connect to the NOT gate, and output is S0 dash, so it will be connected to the Y0, one of the input AND gate, and the input will be connected here. Okay, this input is connected. Next is what? Y1. So what is the Y1? S0 into I0. So one input is directly taken as S0 without NOT gate, and another input is connected to your I0 directly. So this is how the connection will be. Now to see the output, I need probes. In this case, I need two probes. In the multiplexer video, if you have seen, then that we need only one probe, that is multiple inputs to one output. Here I need two probes here. So let me take a red color probe here. So one probe I will place it here, then another one, let me take blue for the other one. So I will take the blue probe here, fine. I will connect the red one to the this one, and this is here. So I am just moving little bit down the circuit. Okay. Now I will change this name of the probe to Y0, and okay, it says that Y0 I have already used, so I cannot use it, so let it be fine. So this is the output of Y0, that is not a problem. Now with this we will simulating the circuit. Now you see, while simulating the circuit, what is the condition, what are the truth table here? Let me just write the truth table quickly here. So S0, then Y0 and Y1. So when S0 is 1, Y0 is equals to I0, Y1 is 0, S0 equals to 1, this is 0, and Y1 is equals to I1, fine. So we will be trying to implement it, testing this one. So when S0 value is equals to 0, then your Y0 is equals to I0. So what is the value of I0 here? Now see, 0. So the output is 0, the probe is not activated or glowing. So if I make I1 equals to 1, then the probe is active, but still the Y1 value is equals to 0. That is my truth table saying, fine. Now if I change the I0 value, that will only appear across the Y0 output, fine. Now if I change my S0 to 1, then what will happen? The output will appear across the Y1 only, then Y0 will be 0 always. In that case, if I change this value, see, then only Y1 is getting activated, but your Y0 is always 0, fine. So that is how you can implement a simple demultiplexer, that is size of 1 cross 2, that we with a multisim, and you can verify the circuit. In the next video, we will see how we can implement a 4 cross 1 demultiplexer as well.